xTool D1 laser. Got it right here. It's one of mine. I have two of these. This one I am going to put the extension kit on. I purchased this. This is not sponsored by anybody whatsoever. This is all something I'm doing. This is going to be done in detail too, in case you want to do it. What you get with this, as far as instructions, is a little card. It gives you a QR code you can scan, and you can go online and you can download their disassembly and reassembly manual. And I did look it over, but I'm pretty adept at working on these because I have so many lasers. So we're going to get into this coming up. I'm Roger, welcome to the shop, and as I mentioned at the beginning here, I'm going to be putting the extension kit on this laser here, which will then give me a work area of about 400 and change millimeters by 900 and change millimeters. And I'm going to be using this to replace one of my other large format lasers because this has more features to it, and the other one frustrated me from time to time. So I'll be probably selling that one and using this one. Why do I need the large format? We make porch signs. They are the narrow, long signs like people put on their porch. And while I can do it on here or on one of my other lasers in this format, I have to do it in 2 or 3 parts. If I have the long axis here on the Y, I will be able to do that at pretty much one shot, unless I'm making a really long one. I will also mention the laser I'm replacing. Instead of extending it on the Y-axis, I extended it on the X-axis, which makes the gantry very, very long, and it does this. And it can affect your engrave. So that's one of the reasons I am replacing that one with this one. So, what's in this box with the extension kit? Well, we'll get into that in a minute. But one thing we will need to do with my existing laser here is take it almost completely apart. But first, we'll get everything out of this box, see what we got. First thing you get is a really neat looking block of foam. There's one of our rails. There's another of the rails. And a box I just dropped on the floor. What do we got in this box here? We have some wire ties, we got new cables, got some alien wrenches, and of course the new long belts for the Y-axis. And lots of foam. And that's it. Well, we'll get into the disassembly here, and the first thing I'm going to do is cut off all the wire ties back here. And I do have air assist on this one, which means that the hose will not be long enough now. I'll have to get a longer hose for that. Not a big deal. Get everything cut loose there. And we'll of course need to unplug the head. There is a little clip there that holds that in. You'll need to push in on that clip to unplug that. And it comes out like so. Well, I got another wire tie to cut off there. So we'll set this off to the side. As you can see, I've got the air assist on here. And a hose that's not going to be long enough when I get done. Next, we need to take out the screws on the corners to take the old Y-axis rails off. And it's good to have a little magnetic tray to put your parts in. So you'll have 1 screw on the top of each corner and then 3 on the side. Or I should say on the ends. That's a 2.5 M&M driver if you're keeping score. Well, I should also add on the bottom side, and I'm going to flip this over. We have the shaft right here. This will need to be, the coupling will need to be taken apart right there. That's also 2.5 M&Ms. Let's loosen up the screws on that so you can slide it coupling over and make sure you retain that. You need to take this off and retain that, you're going to be using it again. Now I'll go back taking all these screws out. Okay, on the back side, after you've taken your frame screws out, you got one more screw here. That is for the belt adjustment. You'll need to take that on, retain it as well, because you'll be moving the belt adjustments to the new rails. So I have all those screws out. Now when you look at your new rails, you'll notice one of them has 4 holes in one end. That is your left rail. So that will be going on this side. The other rail has a bearing in the end. Well, you can see that right there. That's the right side. That will be going towards you to the front. You'll see there's a slot at the back right there. That's going to be for your belt adjustment. That goes to the back. Same as with the left side. That goes to the back. So you'll have your pieces laid out like so. I'll take this apart. So I do have wire ties here on this. I'm just going to unplug the stepper motor here. I'm not going to take all the wire ties apart. Now your cable that goes back to the gantry, that's plugged into your motherboard here. You need to unplug that. There's a white one and a red one. And be careful not to damage your little Wi-Fi antenna thingy there. Now to unplug the white one, there's a little clip on the front here. You're going to have to push down in order to unplug the cable. You can't just pull it straight out. You're going to have to push down on that little clip. Okay, the red one there, you should be able to just unplug. Like so. You set this off to the side, retain it. Again, be careful of your little Wi-Fi antenna there. I'm going to slide the gantry here up a little bit. Take the back off. Now on the sides, I'll lay this down so we can see this. You see right here for your belt adjustment, you need to take that screw out. 2.5 M&Ms. You need to do that on both sides. And remember, this is a round head screw, not a flat head like the ones putting the frame together, so remember that. Now you'll be able to slide your gantry off of here. On this side, you'll see you've got 4 screws there holding the stepper motor on. You'll need to remove those and retain the screws and spacers. You're going to be putting that on the other rail. Okay, and the size for these screws are 2 M&Ms. And you can use the enclosed tools. I choose not to because I like to use these ball drivers. Here again, make sure you retain all your parts. Don't lose the spacers. You're going to need those. Now you can remove the other gantry. Take note on the end that the belt passes through this little plastic guy right here. And the belt just slips out. On this end, you're going to need to disconnect the stepper motor from this cable because this cable won't be long enough now. We can set that off to the side. Of course, you're going to be reusing this as the X-axis gantry, so we'll just set that up off to the side. And now, taking the stepper motor we just took off, we're going to need to put that back on over here. And we're going to need one of the new belts before we do that. The left front corner stepper motor, little pulley, that'll go towards the extrusion like this. You'll need your spacers here again and the screws. Take your new belt, place it over the little pulley there. And the way I'm going to do this to try to make it easier to align, I'm going to pass the screw through the other side, put spacers on it. You want to have your plug for the stepper motor facing the back of the laser as you put this back on. And we get everything lined up here. Start your screws before you tighten them up. Make sure everything's lined up. And once you have them all started, you can go ahead and tighten those up. So when you're done, it'll look like this. Now for the other end of this, we're going to have to take one of our belt tensioners here. And a little disassembly is required. There's a little tiny set screw right here. Some people call it a grub screw. You're going to need to loosen that up so you can take this pulley, the shaft out, so you can take the pulley out of this bracket. That's 1.5 M&Ms. So you need to loosen this grub screw here, set screw, whatever you want to call it. This little shaft then should slip right out, and it does. Take your pulley off. You can take the old belt out. Now we need to put this onto the new belt, and so I'm going to flip this around so we can get this better view of it. You want to make sure your belt is not kinked up or knotted up or twisted, or thing. You want to get everything straight, unwound, make sure it's square. The teeth should be facing in. You want to take this piece you just took out. Now there's a mounting hole here, or a tensioning hole that lines up with a slot. Make sure that that hole right there is down. So you'll slip this back around the belt. Again, making sure you do not twist that belt or you'll be doing this over. Place your bearing back in there and pulley. Drop the shaft back through the whole caboodle there. Caboodle's a technical term. Take your proper size alien wrench, you tighten that back up. Now I'm going to flip this over, holding this belt tensioner about where it belongs. We'll flip it completely over. And here's where we take this round-headed screw and I'm going to put it back in. That way we don't have this thing flopping around all over the place. And I'm not going to tighten it up real tight, just give it a little bit of a snug. I've got my belt kind of sort of adjusted there. Then again here I'm going to make sure I don't have any weird twists or anything in it. Now for the extrusion on the right side, I've got it laying right here with the adjustment slot towards me because that's where we're going to be remounting this. Again, same procedure. Loosen up the little set screw there. Push that little shaft out. Move the pulley and the bearing. Take the old belt off. Place a new belt in there with the teeth facing in. Place the pulley back in there and bearing. Drop the shaft back through the hole. Tighten your set screw back up. Now I'll be mounting this to the rail here. Make sure your teeth are facing in on your belt. Again, we want the round head screw, not the flat head. I'll just hold that about where it's supposed to be there. And flip it all the way over. I'll get that screw started in there. And I'll just kind of snug it down at a random spot to hold it. Now, I need to put some things back together. So this is the back. So that's going to go back towards the back. Okay, now we're going to put the gantry back on. And this could have been done before I showed putting these belt tensioners back in, but I wanted to illustrate how they went in and which screws to use. So you would just loosen that screw back up. You'll take your belt, and then on the gantry here you've got that slot. So the belt tensioner is going to be sitting like this. You want to pass your belt through those little slots in there, like so. So it'll look like that. Then we can roll this onto the extrusion. I can do this better sitting down. Keeping track of where your belt is, you can just roll this onto the extrusion. Like so. Make sure you don't twist your belt up. Then you can put the screw back into the tensioner. This is on the right side. The left side will be just the same way. It's just going to be a little hard for me to show that here. Once you have the gantry rolled back on there, you can put your rear extrusion back on. Little flathead screws. You have one on the top and 3 on the end on each corner. And I'm just starting these here until I get everything together back here. And once everything is started and square, I'll tighten those up. Now your longer screw, like this here, will go into that remaining hole and it will thread into the belt tensioner, but don't go tightening it up yet, just get it started. Because we're going to be tensioning up the belt after we do the front end. So now I gotta do the same over there. And once they're all started, tighten them up. And don't forget the belt tension screw. Now we'll move back to the front. Okay, back up here in front, we'll be doing the same thing again. Get everything kind of lined up here, squared up. Make sure all your ports are lining up here like they should. We'll start a screw on the top on both sides. Just kind of hold things together. Not tightening it up yet. Then 3 screws in front on each corner. And again, once everything's in there, go ahead and tighten them up. Now we're ready to put shaft back in. So for that, we need to turn it upside down. Now here's where you're going to need to pay close attention. This will be the belt. This is the right side, but this is upside down. This is now on my left. I'm holding this up to make sure there's absolutely no twists in it. And I will take this shaft here, slip the belt over the pulley, then keeping hold of this so nothing twists or moves, I will set that shaft into the bearing that's right below the motherboard. Like so. I'll take the coupling, I'll slide it over the shaft here, line it up with the stepper motor, and slip it 50-50 on there. I know you probably can't see that, but it's right down there. And then we'll tighten those screws back up. Make sure that you are in the bearing and that your belt is on the pulley before you tighten up that coupling. And while you are under here, you can plug your stepper motor back in. Okay, for the cables, there are 2 different ones supplied. I have the xTool D1 here, which would take this cable here with the white plug and the red plug. This would be for a different model. I don't know if it's for the D1 Pro or what, but it has 3 plugs. And this would not work on my motherboard because I do not have any place to plug this yellow one in. So I will be using this one here. They are both appear to be the same length. And they are. This is where things are going to differ a little bit from factory because I may be adding a drag chain to this. So I am going to plug in my cables and then I'm going to do a little playing around with a drag chain because I did put that on my other D1 laser. But to plug these in, it'll just be the opposite of when you took it apart. These are keyed, they only go in one way. You shouldn't need to force anything. Okay, so when you are done, it should look like this, and then this cable will run up and be wire tied along the bottom and then flip up over the top to connect to the rest. As I said, I'm going to play around here a little bit, see if I can't put a drag chain on here. If not, I'll be running it the way they show. So the next thing we need to do here is set some belt tension. So I'm going to turn this around with the back towards me. And I still have this upside down because it's easier to see belts and everything. So for belt tension, first you want to make sure your gantry is square on there. I'll pull it all the way back. Everything looks good there. You'll need to loosen this screw right here on the side. And then turning your long screw at the back here, you can set your belt tension. Okay, how tight is tight? Well, you don't want it to be like a rubber band, but you don't want any flop in there either. It's kind of subjective, and something to keep in mind is you will need to probably adjust this again after a period of use, because these belts do stretch over time. So once you get your tension set, tighten that screw back up there on the side to lock it. I'll do the same thing over here. And this one here is just like way loose. So we'll get this pulled up a little snugger. Looks pretty good. Tighten that screw back down. And I'll flip this over, make sure everything moves smoothly. Make sure there's no twists in your belt anywhere. Make sure you're on all the pulleys where you're supposed to be. So everything's looking good here. Now I'm going to do a little playing around with a drag chain idea. Well, several hours later, a little finagling here, we have a drag chain. And of course I haven't actually run the laser yet, but I do have nice smooth travel here. I did not have to extend any cables. They were long enough to do this. However, my airline here I am going to have to extend because I don't want my pump sitting right here. So I'll have to put a coupling on there, a little bit longer airline. This did follow into the drag chain well. This is 10 by 20 drag chain. And I basically did the same thing here as I did on my other xTool D1, except longer. And I could have probably done a drag chain across here, but didn't have enough left. As I was thinking about it here, but might do it in the future, we'll see. But now I need to get a computer hooked up to this and make sure everything travels, make a few changes in light burn. And actually I'm going to identify this as a new laser because it's going to have a whole different size to it. So I need to get cleaned up. Boy, I sure made a mess here. I just created another laser. I did it manually because I already have an xTool D1 in there. So I didn't want to duplicate that, and I marked this one here as with extended so that I don't confuse it with my other one. But got that all set up. We'll take this home. Yeah, I'm going to take this home. There we are home. If I would have made my drag chain just a little bit longer, it probably wouldn't curl up in the air quite as much. However, I would not have had enough cable to reach the stepper motor then, so I had to kind of compromise. Okay, I got a little square drawn in here just as kind of a little test line engraved. I'm working with absolute coordinates, so let's take and frame that and kind of see how the drag chain works there. It does go up in the air quite a bit, but it does not sag into the work at all. There's framing my little square. It's just a little test scrap I've got sitting in there. So I will start that. Do a little quick burn here of a square. And it did it. Okay, ran into a little bit of a snag, but it was actually an easy fix. When I went to do home on this, when the laser head was down here, it only stopped halfway up. It wasn't seeing the full 37 point, or 30, yeah, it wasn't seeing the full 37 inches or 936 millimeters. It was still seeing the old limit as far as travel. So what I did was I went online and downloaded xTools. It's called like Creative Space or something. You install that, connect your laser to it, have it check for firmware. Needs to do a firmware update. It'll do it right through the software. I mean, it's super easy. There's a little switch in the back of the motherboard. You got to switch over to upload. It's marked. It's right down there. Let it do its upload. It'll tell on the screen. It takes maybe 10 minutes. And then after it does its upload, it tells you to turn the little upload switch off. You do that. Click confirm, go back in the light burn, and I can frame everything and everything works here. So now when I head home from a lower space down here, it's not going to stop halfway up, it's going to take the whole travel. This will also let you see how the drag chain works. It does work fine. It sticks up in the air quite a bit, but this is not going to be an enclosure. I'll be using this in open air. So as you can see now, it homes all the way down, and I have a project set, just a little square that will engrave clear down here. My little test piece of wood here. So I'm going to click this to frame that, and it's going to send the laser down here. It'll frame that down here where it's supposed to be. And I'll just start this little box down here. So if you have put this extension kit on and you're running into that, because this is, I've had this a while, so it had an older version of firmware on it, probably before they ever decided to have an extension kit. There is also a G-code thing you can change, but it's better to just update the firmware. So what's next for this? Well, I'm going to have to make a new baseboard. I'm going to have to make a new grid. I've already designed a grid, but I need to have the baseboard for it. And to do that, I don't think I've got anything in my scrap pile over there. It's going to be the right size, so I'll probably go to the local lumberyard here. It looks like 24 by 45. I'll probably go 24 by 48 because I could buy a panel already that size. I won't have to cut it. Yeah, I don't think I've got anything over there big enough. I will take a look, and once I get that, we'll come back here. I'll put the feet from my old board onto this one, and we'll burn a new grid. Okay, it's the next day. I just got back from getting some MDF to use for a base on this, and I'm going to get laid out. And yes, you can laugh at my look, but it's snowing, it's 5 below 0 Fahrenheit, and the wind's blowing out of the north at about 20 miles an hour, which has just a ridiculous wind chill. So yes, I'm cold. Going to get warm, going to move some things around. We'll get this baseboard set up. No, not very pleasant out there. And this is just a startup. We're supposed to get like 8 inches of this and 50-mile-an-hour winds. We'll have a flat-out blizzard. So, time for the new baseboard here. As you saw, I went out in the really not so nice weather to get some MDF. Got a piece here, it's 2 foot by 4 foot. I have put feet on here, little rubber feet. These are actually cutting board feet. And I've got to where I'm putting this on all of my baseboards now for all of my lasers, because it not only keeps it from scooting around if I have it on the saw table here, which is very, very slick, but it's easy for me to put my fingers underneath it to pick it up. So now I'll get this flipped over, I'll sand it down to 220, and then we'll get the laser set on it, and I'm going to put some feet back on it, and then we're going to do a grid. Okay, technically I could have made this baseboard 24 by 46, but I didn't want to mess around with the saw, just cut 2 inches off, so it might be a place for me to like set stuff. So now I'm going to put the feet back on here. I'm going to use the same feet I've used before for the xTool D1. However, I am working on designing some risers that will work like what I've done on my Morture LaserMaster 2, on the LaserMaster 3, and on the Dakota L1. The Lego style that'll stack up. And yes, I have riser legs for these, but I also have another xTool D1 and I do not have enough riser legs for both of them, and I like to tinker with my 3D printers. So for right now, I'm just going to put the original feet back on here. I don't know that I will need to raise this, but in the future I'll be putting the other risers on, and I'll do a little video and showing how those work. The mounts consist of these little 3D printed parts right here. And there's, I'll put a link in the description on where you can download these on Thingiverse if you have a 3D printer. If you don't, I can make you up a set. Or if you'd like to wait till I get the risers designed and printed, you can take a look at those. Maybe you'd like to have those instead. So I'm going to get this mounted here. And why do I use these? Because when I engrave my grid, if I need to take this laser off for any reason, when I put it back, it will be in exactly the same spot. So my grid will always be accurate. I just need to set these on the corners and get aligned and screw them down. And a solution to my air assist little dilemma there I had with that being too short and tubings being different sizes. I've got some of this vinyl tubing. It's the same as I used for the water supply on my Monport laser. I'm just going to stretch a bit of this out, cut it off and make it long enough to be handy, and it'll be about there. And this, after I warm it up a little bit because it's cold in here, should fit right on this. And it does. And if I need to take it off, I can just unclip this. And if you're not familiar with these, if you push in on these, you could pull your tubing back out like that. And then to lock it in, you just pull that little collar back up. Yeah, in case you're not familiar with that. So let me get some things connected here, and we'll get going on burning a grid. Something that's important here when you're burning a grid is that you need to focus your laser on the baseboard or your spoil board or whatever you're doing, because that's where you're going to be engraving. And in some cases you may not be able to get your laser low enough. I should be able to on here. I've done this before with these. And I can drop it right down there. Put the little kickstand back up. And now I'll send this home. Opened up in light burn here. We got the xTool D1 extended selected there. I'm all connected. There's what my layout looks like. Need to bring in or open up my file for the grid. It's a 400 by 900 grid I'm putting on here, and it looks like this. I got to make a few adjustments over here. That is going to be 4,000 millimeters per minute. 90% power. That would be the main set of lines. Oops, get back here. And we want to do that in 3 passes. Now the next set of lines, which would be the cross lines and the X, that's going to be at 4,000 millimeters per minute. And 100% power. And we are going to do that one in 5 passes to make a nice dark line. Next are my little numbers there, and these are completely optional. We are going to be running at 4,000 millimeters per minute at 75% power, and that's a fill. So I need to make sure everything is centered here. I'll select all, which is Control A. Little bullseye up here. Oh, there we go. Now I got everything selected. Sure that's in page center there. We're good. We'll need to do some focusing here and get the laser homed, and we can get this started. And how long is this going to take? 1 hour, 4 minutes, and 4 seconds. And it's going to make some smoke in here because I can't vent this room a whole lot today. But I'll open the door from time to time, let smoke out. So now, even though I am working from absolute coordinates, I'm still going to frame this to make sure that nothing is going to bang into itself somewhere, because I designed this grid. I did it in CAD and then exported as a DXF, then brought it into Lightburn. If you would like this file, there'll be a link in the description of where you can go on our website to download it. It will be a Lightburn file, and it will be all the settings will be in there, and it will be for the xTool D1 with the extension on it, 10-watt head. If you're using something else and you want to use that grid, you're going to have to make some adjustments. There's no charge for that. It's just I like to help fellow laser users, so if you would decide you would like to download that, feel free to. So let's frame this here. I have my framing speed set pretty slow, so I can watch things closely when I'm actually doing a project. I probably could have sped it up for this, but we'll let it run at its normal pace here. And while this is framing, I'll mention some more about the grid. I did not put numbers every 10 millimeters or every centimeter. There's 10 millimeters in a centimeter for those of you that are metrically challenged, and my whole layout board is done in millimeters. It's all metric. It's 400 millimeter wide on the x-axis, 900 millimeters on the y-axis. There is a cross on the center, and there's an X. So everything will mark the center because I always operate from center, and it'll help me when I lay out my projects. After this grid is burned, I will probably add another rectangle on here for the signs we do, because that is 5 1/4 inch nominal wide cedar that we use all the time. And it'll help me get my alignment this way every time, because that doesn't work out to metric measurements exactly. So we're on our way down here, then it'll head that way, then it'll head back, and as long as nothing runs into itself somewhere, and it doesn't look like there's going to be any problems, I'll get it started. I am using air assist, by the way. I do have air assist on. It helps to blow the smoke out of there and keep the lens clean and all that kind of good stuff. It also keeps the soot off the spoil board. You do not have to have air assist, but it's nice if you got it to use it. Your actual work area here is 432 millimeters wide by 936 millimeters long. I did not want to go to the max. I didn't need to for this grid. That's why it's 400 by 900. Okay, everything looks good there. I'll hit start. And we'll check this from time to time. See how things are going. It's going to run a lot of long lines here. So I'll also let you see how well that drag chain works. Warmed up outside. Now it's only 0.7 below zero. And there's a reason that the drag chain is elevated at the motherboard end here, and this is why, right there. Because if you did not elevate that, the drag chain would run into itself. That's why this is elevated a little bit right here. That's just a 3D printed part. And there are holes drilled and tapped into that extrusion. And yes, I did take the motherboard out before I did that. Here again, you can see how close it is, even right there. So there we have it. It's headed home. And I have a grid. Here's a look at it from the back facing forward. As you can see, I got a nice layout grid. And I can always know where center is, right here. And if I would like to in the future, I could add a circular or square or any other type of template I'd like to put on there, because that will always be center. And with these mounting feet I have on here, should I take this off of the base and put it back on, it will always be in the same spot. So there's the layout grid, there's the extension kit, there's the drag chain I added on, and temperature's dropping. Now it's 2 below again, so much for the warming trend. And it's still snowing out there and it's still blowing, so I'm gonna have to bundle up. Okay, if you would like to get this grid, there'll be a link in the description of where you can download that. It's free, there's no charge for it. If you'd like to know where I got the components for the extension kit, there'll be a link in the description for that. Bought it directly from xTool. For the drag chain, should you decide you want to go that route, there'll be links in the description of where I got this drag chain. You will need to buy 2 of them, because one of them will not be long enough. Then you'll have some left over for another project. I kind of have a stock of that for these different projects I do. This little riser block here, you can either make something on your own, or you can send me an email and I can send you the STL file to make that, or I can make you one for a modest price and send it to you. If you have a 3D printer, you can print your own. It's very simple to do in Tinkercad. It's just 2 blocks put together. Not tough at all. So I know this video got to be a little bit long, but there was quite a bit involved with this, and you may have saw in the front here I added some little wire management clips. Those are 3D printed. You go on Thingiverse, you can find all kinds of wire management clips you could print out if you have a 3D printer. And it's a good way to use up ends or rolls of filament, little projects like that. So if you got anything out of this, appreciate getting a thumbs up. Always helps the channel. Again, nothing sponsored here. I purchased everything. Thanks for watching. I'm Roger in the shop. We'll see you on the next one.